How are you doing? Good morning. So I'm excited to talk to you guys today. Math 7. I'm hoping you guys are staying safe and healthy. And I know I keep saying this all the time, but it is important that you guys are staying aside, abiding by the regulations of our government right now, and just staying healthy. Let's pick up where we're leaving off. So we're going to talk about IQR today, which is called interquartile range. I'm sorry I keep blinking. It feels like I got something in my eye. We're going to talk about the interquartile range, all right? Prior to talking about that, though, I know I've seen a couple comments on the last assignment I gave you guys on Delta Math regarding box plots and the percentages, and if you knew anything about them. And I want to look at them quickly and just go over it. I did mention it in the last lesson I gave, either 9.1 or 9.2, but I want to make sure that I fully cover it now, or at least touch back on it. That way there is no misunderstanding. So I'm going to share my screen with you just to look at a couple problems that are on Delta Math first. And then we're going to dive into this lesson that I need to cover with you today. All right, so if we look at this one here, and awesome. This one says the box in which the plot below represents some data, right? What percentage of the data values are less than 75%? Now, it's asking you what percentage of the data are less than 75. This is understanding that 75 is here, right? Less than 75 is right here. You should be able to identify that this is what value on this box plot. What value is this? This is the quartile 3. That's quartile 3 that we're looking at right there. Because that's quartile 3, you should know something about quartile 3. Quartile 3 takes up about 75% of the data. Now, how do I know that? Because each one is about 25%. And I'm going to draw it for you real quickly to separate them so you can see why I'm saying this 75%, right? We got quartile 1 right here, right? This line right here represents quartile 1. That's 25% of the data. Quartile 2 is right here, also known as the median. That's another 25% of the data. Quartile 3 is right here. That's another 25%. And finally, this is the last 25. If you add all 25 up, 25, 25, 25, 25, you'll get 100% of the data. It's asking you what percentage of this data is less than 75. So they're asking you from here and on. So what percentage of the data is this? This is 75% of the data. Now, it doesn't have to be 75 there. Keep that in mind. It could be the number 10. It could be the number 12. It could be whatever number it wants. But you need to recognize, because this is quartile 3, and they're talking about less than where quartile 3 is, how much data is actually taken up here, that's 75%. They could have told you greater than 75. If they would say greater than 75, we would have said the answer was 25%. Right? You really got to understand that each quarter, because that's why it's called quartile, each quarter is 25% of the data. So this is 25% the first quarter, another 25%, another 25%, another 25%. So based on what they tell you, if they ask me, right, and I'm going to give you another example as well, if they were to say to me, okay, looking at a lower quartile, because sometimes it might say upper quartile, it might say lower quartile. You got to understand lower quartile is understanding quartile 1. Upper quartile is saying quartile 3, right? So in this case here, they would say, okay, looking at quartile 1, what's the percentage of the data that's greater than quartile 1? You would say 75%. Greater than quartile 1 is 75%. 1, 2, 3, 75%. Less than quartile 1 is 25%, okay? All right. Let me clear this out. I'm going to do one more example on the Delta Math, and then we're going to dive into looking at what we need to talk about today, okay? That asks you about the second quartile, which you guys should know the second quartile is the median, and we're going to talk about that today a little bit. Upper quartile, what I just mentioned before, that is the third quartile of the actual box plot. First quartile, we know that one. Here we go right here. What percentage of the data values is greater or are greater than 45, okay? So we're looking for the percentage of the data values that is greater than 45. So I would first find 45. 45 is right here, right? If you notice, that's the median. What quartile is that? That's quartile 2. So since this is quartile 2, they want to know what is greater than quartile 2. What's the percent that's greater than quartile 2? That's going to be 50%. Now, how do I know that's 50%? Because if I look here, I'm saying, okay, this is the median, below the median is 50% of the data. Above the median is another 50% of the data. So they want to know what's greater. What's the percent that's greater than it? Is 50% that's greater. Okay? And this diagram here kind of shows you another like picture so you can understand just a little bit better. All right? My wife is laughing in the background. Not sure why she's laughing, y'all. She's probably on Instagram or Facebook like you guys and looking at all these weird posts that keep going up about the quarantine. Cats. All right. Anyway, all right. If you have more questions on that, please feel free. I do plan on adding the videos to Delta Math. I'm sorry I haven't done so yet, but I do plan on doing it. All right. Let's look at what we're going to be working on today. So, if you either just worked on the worksheet today, or if you're going to download it, print it, and use it, this is what we're dealing with. Calculating the interquartile range. Before I tell you what the interquartile range is, let's look at the bell work. I want you to, after I give you this box plot, and that's what we're going to really be looking at today. I'm going to give you box plots, and you're going to take the box plot that you're given and identify values on it, right? So do me a favor. What is the first quartile? What is the second quartile? And what is the third quartile of this particular box plot? Take a second. If you need to, pause the video, write down your answers, and then unpause it. So that way you can get, that way you can check to see if your answers are absolutely right, okay? All right, great. So I'm hoping that you was able to take a second and actually get these values. So let's look at it. What is the quartile 1 of this data? What is quartile 1 or the first quartile? What is the data for that? If I look at the first quartile, I notice that the first quartile is right here, is this line here, right? This line is my first quartile. What is that data value here? Now, you also got to be able to read this number line, right? What is it going by? If you notice, the number line is going by tens, 50, 60, 70, 80, 90, 100. So that means the first quartile is 80. Okay, that's an 8. I apologize if it doesn't look like an 8. It is an 8. I'm getting a little bit of glitch in here. Maybe I got other stuff open that I shouldn't have. That's an 8. Let's leave it as 80, okay? What about the second quartile? Now, notice it says second quartile. I normally don't say it a second quartile, but you need to recognize the second quartile is really the median. What is the median of this data? The median of the data is 100. So 100 is the median of our data. So I'm going to put right over here 100. Okay? Finally, the third quartile, which you can see there's a pretty big gap here, but nonetheless, the third quartile of the data is 160. So if you wrote 160 for this, I want you to know if you put 80 for first quartile, 100 for second quartile, 160 for third quartile, you are spot on, okay? Now, we need these data. Why am I reflecting back on this? Because we need these. I know the last lesson we talked about 9.2 actually. 9.1, we talked about quartile 1, quartile 2, quartile 3. However, 9.2, we were talking about outliers, right? We talked about outliers in 9.2, and I think it's essential that we also realize that outliers, we can identify them visually. If we look at dot plots, we can. However, I want you to also know how to identify outliers via something called interquartile range. The interquartile range will help us understand the range of the data that's on the inside, that middle 50%. So all this stuff on the inside, as well as understand how far something needs to be in order to be called an outlier based on a box plot, okay? So we may dive into that, but I do want you to get the understanding of how to calculate the IQR, the interquartile range, and then we may dive into, not today, but another day, how to recognize if something's an outlier based on the IQR. But I like what you guys done so far regarding the dot plots and identifying the outliers of a dot plot. But now I want to look at something called an IQR, interquartile range. So I'm going to clear this quickly. I'm going to read the definition I did have on the paper for IQR, and then we're going to dive into a modeling example that I'm going to model for you what I want you to do in completing your own, okay? So the IQR tells us how spread out the middle values are, right? That middle data. It also can be used to tell when some of the other data or other values are too far from the central value, right? Which is that median, right? How far they are from that median. These two faraway points are called outliers because they lie outside the range in which we expect them, okay? We're gonna learn how to interpret this and how to use the interquartile range to interpret data on dot plots, okay? First, let's talk about understanding how to calculate them. And then we can talk about how to use this new range that we found to talk about whether it's the percent or talk about how we can identify the outlier. But for today, we're going to focus on creating these wonderful how to actually calculate the interquartile range. Okay, it's not complicated at all, believe it or not. The box plot is represented. I'm reading the modeling, right? So the box plot represents some data. We need to calculate the interquartile range. Now remember, range is a specific word that we're using here. And just like when we calculate the range before, we would take the highest value and minus the lowest value to calculate the range. However, the interquartile range is saying we're going to take the highest quartile and minus the smaller quartile to find that range. Okay, so let me first talk about, let's identify what the quartiles are. So quartile 1, we can see is right here, right? This is quartile 1. And I'm just going to make a little dot here and make it where it says Q. Oh, sorry. Okay, let's call this one right here. I'm going to make it and say Q1, right? We know this is the median. I'm going to call that Q2. And finally, this over here should be the actual quartile 3, okay? There are essential components here. Do I need to know the minimum and the maximum right now? No, because we're not creating the dot plots or the box plots. We already have a box plot, right? We're not creating box plots. We're just interpreting them, taking data from them to find other major things that we should know. So we're going to identify what is quartile 3 first. Quartile 3 of this data is 150. Quartile 1 of this data. Now, notice once again, when I read this number line, you have to make sure you pay attention. Is it going by 2s? Is it going by 3s? Is it going by 10s? It's important that you identify what's the skip of the actual number line. If you don't recognize it and you say that's 52 there, not knowing it goes by 10s, you'll end up putting the wrong value for quartile 1. And then when you go to calculate the IQR, you'll have the wrong value there too because you messed up on quartile 1. So this goes by 10. So this is actually going to be 70. So quartile 1 is 70. So in order to calculate the IQR, we need to do quartile 3 minus quartile 1. So we're going to do quartile 3 minus quartile 1, which looks something like this. 150 minus 70 equals our IQR. Now, if you need a calculator, grab one. If you don't need a calculator, it's fine too, right? Right? But you want to make sure you double check it. I would recommend you guys double check your answers to make sure they're spot on and that you're not just thinking of something. Because if you put the answer as 60 and you're like, I know it's 60, I would recommend you check it to make sure it's what you think it is, okay? So 150 minus 70 gives us 80, which means the IQR value for this particular data is 80. That's it. That is exactly what we're doing today. We are identifying these IQR values. We're identifying the interquartile range. And as you go through, you should be able now to identify the mean, median, mode, minimum, maximum, range, value, IQR, quartile 1, quartile 2, quartile 3 of the data, right? This is a lot that we've learned, as well as being able to represent them as a box plot or represent them as a dot plot. These are all foundational things that just definitely going to help you. But right now, I want you to continue to work on it. I believe I made 4 extra problems for you to do. And all I want you to do is calculate the IQR, okay? I did not make it as an actual Google Doc today. This is actual worksheet, so you need to actually just edit it on the worksheet and then take a picture and submit it as we've been doing before. I'm sorry I just didn't get a chance to create or take this worksheet and make it into a Google form. All right, thank you guys so much. Please work on this and get it submitted. Thank you so much. Talk to you later.